right, so we are back on titrations. So before our uh, little pause here in our learning, we started talking about titrations. So today what I want to do in this video is kind of walk you through titrations for weak with strong. So again, strong with strong is going to be much more straightforward than weak with strong. And you are going to have a characteristic, what we call S-curve, when you see that. So this is, again, what we talked about before we had our break. So with strong versus strong, we are looking at kind of a mole-to-mole type problem is really where we do the math type of this. This one was pretty straightforward because I just had to do a one-to-one relationship because it was HCl and NaOH. That's not always going to be the case, but it is an easy way to start the process. So there's going to be 4 things I ask you to do. Find the initial pH from the strong, find the pH after NaOH has been added, find the pH at the equivalence point, and where we finished up was where we are past the equivalence point, we've added some more base to it. So now I'm going to talk you through what happens if I have a weak acid with a strong base. So this is going to be, again, new material that we haven't talked about yet. Okay, so this is characteristic of a weak acid and a strong base. This is typically what you see the curve. And this curve looks pretty much the same except for this region here, which is called the buffer region. And I'll explain what that means. Equivalence point is going to be in the same spot, but the curve itself is very different. So again, I will come back to this as we go. So strong base is NaOH and acetic acid is a weak acid. Okay, you're going to see acetic acid as HAC in all of my notes, so just keep that in mind. So the HAC is going to react with the sodium hydroxide, and we are going to produce water and sodium acetate. Okay. As I've been mentioning before, the H on that weak acid is going to be ripped off by that NaOH. Okay, so it is not acting like a typical weak acid where that H only comes off partially. When you add the strong base to it, it will take off all of the H. So when we are looking at a weak with a strong, we're going to have what we call a different net ionic reaction. Okay, so the net ionic reaction is not going to be like we saw with the strongs. Strong was H plus OH minus gives me water. Well, here I can't do that to the acid because the acid is a weak acid, so I have to keep the H attached to the anion. Okay, then I have my OH minus. So this is where it looks similar on the base side. I produce water, of course, but then what is more interesting is I produce acetate ion. Okay, and that acetate ion lends itself to some interesting chemistry associated with that. So if I take that acetate, and I'm going to write out the acetate, and I put that in water, it's in an aqueous system, it's going to, of course, take on an H. It doesn't have an H. That H is not acidic H, so it's going to take on an H. So you're going to make HC2H3O2, and you're going to be making OH minus, which, of course, is going to make this a basic solution. So what you will see is the equivalence point is no longer at 7, it's going to be somewhere higher because of the fact that the ion that you produce is a basic ion. So that's where it's going to be a little different, and I will come back and talk about pKa and some other things there. But that's the background to what you see with weak acids.